In two previous videos, we opened the head of the vacuum cleaner, and we also opened the actual motor of the vacuum cleaner, the Vax vacuum cleaner. As you see, there are two motors. This is the head motor, and this is the motor, let's call it main motor of the vacuum cleaner. So what I'm going to do now, I'm going to open one of these and see what's inside them. So what's happening is that we have permanent magnet here. As you see, these are magnets. So if I put my screwdriver here, it's going to attract my screwdriver. So we have two permanent magnet. That's why this motor is called a permanent magnet. It's also a DC motor, 21.6 volt DC, and it's a permanent magnet. These permanent magnets are the part that are providing the magnetic field for us. And these are called stationary because they're not going to be moving when the motor is moving. Those are stationary. At some point, we want the magnetic field to be perpendicular to these wires. These are copper wires, so that we can use if it's a motor, so that we can use the force of the magnetic field to move this shaft. And if it was a generator, we needed that to be perpendicular to the copper wire so that we can generate electricity. So the internal structure of the motor and generators are almost the same. The only difference between motor and generator is that the generator will receive the mechanical movement. So the generator will receive this and then will make electricity, but the motor will receive electricity. So you will connect your motor to the electricity, as in vacuum cleaner, for example, and then it'll make you mechanical movement. And then by using different elastics like this, then you can change the mechanical movement from one thing to another thing, or from, for example, horizontal, from rotational to vertical, or horizontal, or whatever you want to do. Permanent magnets motors are they have a simple structure. So they have the stationary and the rotor, the part that is moving is called rotor. These copper wires are going to be perpendicular to the magnetic field that these two permanent magnets are providing, and that's when they're going to force and push this shaft, and the shaft is going to move. All right, so I opened this permanent magnet, which was the head motor of the vacuum cleaner, and that was the main motor of the vacuum cleaner. And they're almost the same. Here you can see that negative and positive, or if you want to say active and neutral, are going in, and they're turning the motor on. So they're going, and the internal structure of the motor is like this, which I explained.